It's Monday night. It is 9 p.m. That means it's time for Let's Make It. Today is July 7th, 2014, and this is episode 56, if I remember correctly. And tonight, Bob is back with me. So, how you doing, Bob?
I'm doing good. How are you?
Doing good. Have an okay 4th?
It was quiet. It was all right.
You see any fireworks?
No.
You don't
hit it. We kind of hid in the house.
Okay. You're too old for fireworks, right?
No, I love a good explosion. I just wasn't feeling that great Friday, so.
All right. So tonight, Bob has a bunch of things for us. Some things we've been working on. An extension to where we left off with TVOut from before, and I have a few things I want to cover. I know we originally planned on talking about creating a library tonight. I have the library created but not debugged, so it's not functioning 100%. So that gives me an extra week to get that done. So we will come back to that maybe next week. Before we go and look at what Bob has, though, because I think he has a lot tonight. He's scaring me a little earlier in the email. Let me show you a couple things that I've gotten, and also give you a quick update on a couple of projects. Let's do projects first. So my Beehive thing, I know Jim in the chat room's been emailing me things for this. I have the solar part of it done. It's outside sitting and charging via sun every day, and I haven't done any kind of load test on it to see how long it runs things, but based on calculations, it should run things for about 2.5 days on a full charge, and should be able to charge it within 6 hours. So I should be good to go with that. So far, the charging is working great, though. I have gotten some things in for that project, and I'm going to show you to you here. The quadcopter, I should take pictures before I came in here. I've been working on that for the last couple of weeks. Actually, the hexacopter is what I've been working on the most. And I have everything but a couple small plugs. It's amazing how many different types of plugs there are for batteries. As I started going through this, there's bullet plugs, which I have some on the way, which are easy to make, and then there is plugs that are straight on, and there's plugs that are straight on one way and twisted the other way. So all these different types of plugs, depending on what battery manufacturer you get it from, makes a big difference. So it's been one of those things where I just have to get all the right parts in. It's pretty much assembled and ready to go, except for I'm waiting for one piece of wire and a plug. All right. So here's some things I've gotten. I want to explain a little bit, because we can talk about this in a few episodes coming up. First of all, this is an open source quadcopter controller. Actually, you can do an octocopter. I believe this one can. Open source. It basically runs the same chipset as an Arduino, and you can program anything you want. It's an open source project. You can download everything. It's very interesting. This is going to be my one quadcopter, and it's going to be this controller right here. And Bob in the chat room will know what a couple of these things are. This is a Teensy. This is an Arduino. It can be more than Arduino. It doesn't have to be an Arduino, but I have it loaded right now with Arduino code. So this is what I'm going to use in the B counter project. So I haven't even gotten started on that project yet, other than I got this to learn a little bit how it works. But I am going to start using this as the tiny Arduino, and I'm going to use that for each Beehive for the controls, or to monitor everything. So got those in. I haven't even had a chance to plug this one in yet. This one I've loaded the Arduino code on, so that's good to go. And then this is a new CPU. And if you ever used DDWRT on a wireless router, you were using one of these. This is what this is inside of most routers that support DDWRT. I'm looking at this to replace some of the Arduino stuff that I'm doing inside my controllers, because the Arduino stuff I've been using isn't quite powerful enough. I have been playing with the new Arduino Galileo, and it is fast enough, or it appears to be fast enough. However, its boot time is quite long, and I'm just not happy with that. So I'm going to start playing with this, and I have a development kit as well that's out in the other room plugged into the computer. I didn't bring the whole thing. I just brought this in. So that's something when we start talking about in the near future too. It's rather inexpensive, has 2 built-in wireless on the chip and everything. So it has network and all that stuff built into it. So that's actually interesting. So one of the other projects I'm doing is I'm doing wireless tally, and the requirement was to 1,000 feet. So I'm looking around for wireless. This is a 900 megahertz, 958 megahertz, I think, wireless serial device. And supposedly, with the right antennas and direct line of sight, you can do up to it's 40 some miles, or maybe it's kilometers. Either way, it's a lot longer than what I need. With the base antenna, supposedly this thing will work up to 3 football fields, which is probably about what I need what I'm looking for. So something else to be playing with. Again, it's serial, and it does up to whatever double of 115 is, 230 something or whatever the high speed is for that. So look for that in an upcoming episode as well. So lots of new things came in this week. So this week
you have all these new parts. I've just been playing with the TV for the last couple of weeks.
Did you get Pong working?
You know, I've thought about it, but every question that I was getting was about text display. Not,
okay.
I did not get a single question about gaming or how to display any of that. So I focused on the questions that and I've gotten quite a few over the last couple of weeks. So
yeah, and I saw in the chat room that Jim mentioned about defined fonts, like custom defined fonts as well. He said user defined fonts, so that's a text-based thing as well.
Yes, and actually I have those files open right now. So I've been playing with the library with this project as well, or this demo. I've got a modified library too.
Good. So you ready to roll?
I think so.
All right, it's all you.
All right, well, let me first switch to my desktop, and then you'll get to see everything in reverse. And I'm sorry about that, but it's the only way I can show code and have people see what's going on at the same time. So hopefully you can see me now. So I believe what I have loaded right now, this is the code that we used a couple weeks ago. The only thing I've changed here is I'm now running on a Mega instead of the Uno that I was using 2 weeks ago. And I'll just upload that code again to get it restarted.
So do you want to explain why?
The problem I ended up having, and I didn't have it in this sketch, but the next one I had a memory problem, and I couldn't figure out why I was struggling so much. But I wanted to show this before. I did unplug my Uno and just replugged in the Mega and these pins, and all the code picked right up. Nothing changed. And let me switch cameras. And here is the whole setup that I have for tonight. And I've added a couple things to it. I have a little speaker now, which I have one little piece of a demonstration of how to use a tone, and this is a 8 ohm half watt, so not very powerful, and it's connected through a 100 ohm resistor, and I have my 25 pin keypad that I've used a couple times before. This is ground for everything, and here's the video out just like I used a couple weeks ago. So
what's under your speaker?
What's under the speaker?
Yeah, what's it sitting on?
Oh, just a mouse pad.
Oh, okay. I see it.
Yeah,
I see it.
Here's the free plug.
Yeah, there's a Mauser. It's backwards, but that's okay. You can see what it is.
Yeah. I'm a big fan of Mauser because I can drive there and get parts in 30 minutes.
From here, it looked like it was a box of some kind, so that's why I couldn't tell what it was.
No. It's kind of funny because this is sitting on my desk, and the desk is kind of a black glass, so it reflects.
Yeah.
You're actually looking at it. I'll switch cameras again. You can see it's all sitting under the TV right now.
Yeah. Okay.
So, so I switched to the Mega because when I got to this file, and I'll go ahead and upload it, and of course this is where. Now I put in a couple things here. The first is that I put in this delay at the beginning of it, and then I wanted to see what the size was. And did you hear that?
I heard that, yeah.
Okay. All right, that's my little contribution to music on the Arduino. I spent probably 30 or 40 minutes jacking with that code, trying to get that sound to play, and then I got my wife to look at the music. 5 minutes later, it was working. It was really annoying that I wasted so much time. But hey, she can read music and I can't. So. But what happened with this code right here, what I discovered is that the TVOut is using RAM, using active memory. So on an Uno, you only have 32K of RAM of memory to start with, and you have half a 500 bytes is taken up with the bootloader, and you add some code, and the standard display is 100. Where is it? Standard display is 120 by 96, and I've increased my demo to 136 by 96. But the standard display is 120 by 96. Well, you do the math, that's 15.5K right there. So you add the bootloader, add some memory for variables, and now instead of having 31K of memory to work with to upload to the Uno, well, I was down to 12.
Right.
And I couldn't do anything. So this sketch right here, I mean, you can see it's 20K all by itself. I mean, you do the math, you run out of room on the Uno very quickly, or at least I was.
Yeah, and I mean it's a big jump going to the Mega too.
Right, and now I've got gobs of room that I've got far more memory than I have resolution available in this library. So it was just and then of course in the code that our friend Jim from Canada sent me that I modified, I put in that 25 pin or 25 key keypad. Well, that's got its own library with a couple K worth of memory. Yeah, so I really didn't have a lot of choice to be able to do anything.
And then they add fonts, and it just keeps growing.
That's right, and it becomes very difficult. Although I did find one thing on the net that I'll show in a little while that runs on an Uno perfectly, and I did test it. Although tonight, we're going to look at it on the Mega, and of course I don't have well, we'll get to that in a second. But this code, it's pretty basic. I am using for this television. I just liked the wider. Rather than 120 by 96, I went with 136 just because it looks nicer on the screen.
Do you know what the maximum size is?
There is a limit, although when you start going up in Y, there is a noticeable slowdown. With 96, this display is updating at roughly 60 hertz.
Okay.
So the formula for the timer is based off of the Y resolution. So you go up on the Y, you slow the refresh rate.
Okay. So Jim wants to know, how do you check the number of bytes used on the Uno? And the way you can tell that is when you upload it. At the very bottom, you see right there on where he uploaded it, says the sketch uses how many bytes of program storage space, and then it says the maximum is, and that's where you would know how close you are.
Yeah, so not only do we have, so this number is the one we have to worry about. So this sketch, just over 20K, and then global variables are using that. It doesn't actually tell you local variables when they're being allocated and deallocated.
Right, that's only what it's fixed, like a static.
Right. So, and that's why, and if I come over here to Jim's, let me compile his real quick. See, his is 13K, almost 14, and it just wouldn't fit anymore on an Uno. So that, yeah, here, Jim, here's your code, here's your modified code. So, but in this one, how in depth do you want to go with this, Mike?
You can go as in depth as you want.
Okay. Well, I'll just kind of skim through this because I've tried to be good about commenting. Essentially, what this first this TVOut demo file is I changed to some variables for some things, and then I have I have our intro, and this is I put this in because I needed a delay. Let me go back to this one, and yeah, watch the TV. When the TVOut logo starts coming down, you're going to see it shift in X. Do you see it there?
Yeah, I saw that.
Okay. That seems to happen everywhere. And it got to be real annoying, and I could never figure out where it was coming from. But it's in the way the timers are getting set up. So I put this little delay. I put this intro in more than anything else, just so I had a standard delay before I got started. And then I created this, play charge, just because I wanted something to play sound.
Right.
There it goes. And then I took the cube that is in that's in the basic example that you get when you download the library. I just turned it into its own function. So
okay.
Somebody could strip that out and use it somewhere else, and now it's pulled out of the because it was running right out of the main loop, which isn't very useful if you want to move it somewhere.
Right.
So this intro puts we're using the print function. We're drawing a line across the screen, having a delay. All I'm doing is printing a period across the screen, and then this code right here, just centers things on the screen so it looks nice. And it's it gives some examples of how you can format things and center things, and and that's the questions that I was getting leading up to this demonstrate. This demo was putting things on the screen in text, and how do you do that? And so that's where this came from. And then for the charge tune, I've got in here, where I got the tune from, where I got the frequencies from, and it is connected. I took it. Let me back up. For the display, we talked about this before. The display for the TV is running off of timer 1 on the Uno or the Mega. The audio is actually running off of timer 2 because it's got to get a higher frequency rate. And I'm using pin 11, pin 10, just like it says here. I didn't move any of the pins. And it played once I got my wife to, get me straightened out on the music, it picked right up. And so, and then all I'm doing is I set the value, the time value for how much a note is, and I put a small delay in between notes, and I just play the 6 notes of the tune at the appropriate length of time, which is why I was getting it wrong, is because I couldn't read the music. So, and once I did that, it was all good. So I'm gonna.
So the TV library has sound functions built into it then?
It has the basic tone functions built in.
Okay.
So all you've got to do is give it a frequency. And, so that was, I figured charge was...
Yeah.
Okay, for me, I needed simple. So,
yeah, that's fine.
But you can, if you can generate a frequency, then you can generate the sound. So, and then these functions down here. Now this is where I did play with the library a little bit. Is this get font X and get font Y are actually some of my functions, and I've emailed the author of the library to see if he wants me to put these convenience functions. I actually didn't find anything functional in the library that I thought I could improve on. Everything I've done is just being convenience for, where do you get the X font? Where do you get the Y font? Little things like that.
Right.
So, but for sure I'll have it in the code when we upload the code. But I have asked if the author would like some of these convenience functions to be added into the library. So, okay. So here is Jim's code, and I'm looking on my other monitor to see if he's talking to me yet.
No, not yet. He's being quiet tonight.
Now what he did. This is a nice example of using a scoreboard. Essentially, it's a scoreboard, and the way he wrote this is, you don't. If you come back here in this code, when you start something, you clear the screen, and then you put everything back on the screen again.
Right.
In Jim's code, all he's doing is refreshing the pieces. So if the time starts, well, then only this little part of the screen is actually being changed. And to help with with the functioning of the code, this screen actually only changes once every second, even though the Arduino is putting it out at 60 hertz. The text is only updating once a second.
Okay.
So this is where, so when we start looking through this code, you'll see a lot of code commented out, and that's because I took out, he was using a 12 key keypad, and I'm using a 25. So I had a lot more keys to work with. But if I come over here and I press the right button, my timer starts. And then we can, oh, looky, Team A is scoring big. Oh no. Team B's coming back. So, it's and then this bottom part right here is actually it's a debugging code that shows you which key. So if I press the delete key on my keypad, it tells you that that's the key.
Oh, okay.
So if you were going to use this in the real world, of course you'd take that out. But for when you're debugging this, okay, it's real handy to have.
Yeah. So you can tell what's being input.
Yeah, tell what's being. So. And of course, this right here is the character code that's coming up. So if I press a 1 to add 1 will increase Team A's score. 1 is ASCII code 49. And that's actually where and I'm not going to go through this in too much detail because this is the same keypad that I used in a previous demo.
Right. So one of the things Jim's asking about how the 25 keypad is integrated, and if I'm not mistaken, it's integrated basically the same way his 4x4 was. It's just you have more keys to look at.
That's right. And now the disadvantage of this is that I needed 10 pins on something to connect it. So it makes it really easy to use a Mega for this keypad, is because I need 10 I/O pins.
Right. That's one of the things he's asking is, can you use I2C GPIO? And yes, you could do that.
You could. Yes, that's right. Sure could. But I've used this keypad several times before, so I have it sitting around ready for demos. And I think essentially what this whole, all of this code, now this is, Jim's got this set up to run on an Uno, and if he uses his keypad, then this code will run on an Uno.
Right, because there's not enough pins if you're using for your output and everything, and for the keypad.
Right. You don't have enough I/O pins, and you don't have enough memory. The 32K on an Uno just is not going to cut it with this keypad. So some of this, if somebody is watching the previous demo, this code is going to look exactly the same. And this is where I'm capturing all the keys, and you can see, okay, if I press a 0, I'm decrementing Team A's score. Or I can change the period and go up or down on it, or I'm using F0 to start to toggle the timer. I could just as easily have used F0 to start and F1 to turn it off. Now, so I've got a lot of extra keys on here that I'm not using. And then F3 clears the whole mess and starts over. So if I come over here and press F3, everything starts over, and it's sitting there ready for me to press F0 again and start the timer.
Yeah, so Jim's again asks, can you use GPIO to reduce the pin count? Which is, the answer is yes. You could use a chip like a 23017, which is basically a 16 I/O I2C based chip.
Yep.
Fairly inexpensive one as well.
Yeah, the only trouble might be is how much memory is needed for that library.
Yeah, so you can run up against the problem of memory with an Uno.
You're still going to come up with the problem of memory.
Yeah, now is a Leonardo I don't know what the memory is on Leonardo, which is still the same form factor, but I think it has more memory. I'll have to go. I'll go look it up while you keep going.
Okay. All right. So this is code. Now all of this commented code right here. This was Jim's old code, and he had to work hard to get this to work with a 12 pad or a 12 key keypad. It was easy for me to do this, and Jim, you'll like this. This was really the only thing functionally that I changed. Is I rearranged this little bit of code right here. So when the timer finishes the 4th period, it stops. And in the original code, it would you'd get to the 4th period, and then the timer would restart at 10 minutes and continue going and then restart. So I essentially, this turns into the end of the game. So that's really my only functional change. And sorry, I'm looking at the other monitor and seeing if he's saying anything yet, and he's not. So, but this is a very nice demonstration of blocking out the printable area and updating things only as needed. So, and then of course here's where I'm capturing whatever is pressed and displaying it on the screen. So like right here, this left arrow, if I press that, we're going to see a 132 and the arrow sign, and here's where the code's coming from. So, and then it puts it on the screen, and it's a nice, but somebody could very easily take this, rearrange it where you use a different font and have, a larger time here, have team A score, team B score, if they're looking for basketball, have fouls. And
I'm going to guess based on his comment that it's probably hockey, because he goes, "Where's the horn on the relay?"
I thought about that, and I didn't have time for the demo to put a horn in.
So I did look up
but it's set up. It's set up for one. It's ready for it. I just, I don't know what frequency, and I just didn't have time to go find what the right frequency is and add it in. But I guess I can go find that, and when we publish this code, I'll have a tone in for you.
So
He likes that.
yeah. There is a difference between the Leonardo and the Uno as far as memory goes. The same limitation in memory exists on both, so it would not matter if you went to Leonardo.
Oh, okay. Yeah, and that's and also even with when I got into mine at 136, that still requires, even that change requires more memory, because the screen resolution is
right.
So if you go to 136, yeah, see, that's not right. My math is off somewhere, but yeah, you still need more room. But that's essentially that's the problem is memory for this thing. So, but Jim wrote some nice code in here. Okay, the next file that I have, now this is one that I just kind of stumbled across over the weekend, and it was just too much fun to let go. And this is what I found. A TVOut oscilloscope.
Huh.
And now, unfortunately, I do not have anything sitting around that generates a sine wave.
You have another Arduino, don't you?
It generates a square wave.
Well, yeah.
Sine wave.
That's true.
But I've got now. So what I've done is I took this code. Now, one thing note in here: if you download this, it comes in as a PDE file, and I had to go read a little history about this. Back in the pre-Arduino IDE, before version 1 was released, the file extensions were PDE, which is the same as the processing app.
I think I've run into this before with my stuff too. I downloaded something that was a PDE, and I'm like, what is this?
Right. So. Well, it turns out this is an Arduino file that's written in pre-1, in a pre-1 IDE. So I downloaded the code, and the only change, I didn't do anything with it other than a couple little additions, and the code worked perfectly, and you can tell I'm using version 156. So I'm actually using one of the recent beta versions of the IDE, and I didn't have any trouble with it. So the only thing I've added in this code, and some of this I just don't, I haven't studied it enough to get yet, is I added this little variable, which I'm going to use later, because I'm going to simulate. I didn't hook up. This code assumes that you can have a pin connected to pin 2 to change the scale on the or change the sample rate. And I didn't put switches on here, so I simulate a key press later on. So I added that line, and then I added a tone just to give me something to show on the screen. So let me upload this and unplug the speaker. And you can tell, I mean, we're generating a square wave.
Okay.
So it is there. Now, just for fun, if I unplug this, I am getting, this right here is just random.
Yeah, random pulses.
Random pulses just from static electricity from me. So it is working, and it's unfortunately I don't have a sine wave, anything that'll generate a sine wave. But this was too cool to pass up.
Yeah, you get a capacitor in an Arduino could have given you a simulated sine wave.
Sure, yeah, and if I had but I only found this.
Yeah.
A Saturday. So yeah, I just didn't.
So how's it do the scaling? I mean, as far as voltage goes. Because you need to be careful because there's no protection on the pin for that.
In this one, I do have the 100 ohm resistor in place, so I'm not running a straight signal, into it.
What is the input pin for the signal?
It's
analog. Is it analog?
Analog 0.
Analog 0. Okay. Cool.
And I'm generating this off of the audio, which is pin 10.
Okay.
So I'm coming out of the Mega on pin 10, and then reading this back in off of analog 0.
I gotcha.
And since it's a square wave, that's exactly what we should get. And
right.
It automatically formats the screen based on whatever the average voltage is. And of course, it's centering on 2.5 because it's an Arduino square wave.
Right.
It's coming out at 5 volts.
Right.
So we have no negative signal. So it's giving us just what we should have with a square wave. And then if you want to, this little bit of code, if you wanted to change the sample, this -1 leaves it. Basically it's key presses. How many key presses do you want?
Right.
And because I did a little reading about it, and there's more. If you continue on reading all of this, you'll find that there is a limit around 8 kilohertz. Is as fast as a sample rate as you can get, and that's an Arduino limitation.
Right, because it doesn't work any faster than that.
It's just not going to work any faster.
Right.
So, which for a lot of things, 8 kilohertz.
Yeah.
So, but you can simulate a sample rate. So here, we'll simulate 2 key presses. Actually, that's 3 key presses. I'm sorry. I start at 0. So now we're sampling at roughly 1200 hertz, and now we're actually seeing the 200 hertz square wave that I'm generating. And that, I think I skipped past that. I'm sorry. Where is it? Okay, right here. Okay, so I'm using the TVOut tone function to generate a 200 hertz signal.
Okay, so that's how you're generating your wave. Okay.
So I'm generating this 200 hertz square wave, and that's what we're seeing on a 1200 hertz resolution.
Okay.
But this was just too cool to pass up.
Yeah, absolutely.
I mean, we've talked about, there's another Arduino oscilloscope that I've tried, that I tried to get working, and I never could get it to work. So I'm looking forward to having a need for this and actually getting to use this in real life. But now here's the picture of it with the library. So. And it uses this TVOut library just like anything else. So,
yeah, I guess it's important to note though. You just don't want to. The input pin on the Arduino cannot handle more than 5 volts.
Right, it can't handle 5 volts, and it can only handle 50 milliamps.
That's.
I'd have to double check that.
Yeah, I don't know what the input is on it.
I didn't have to worry about overloading it, but yeah, you have to put in some protection, and you can't go over 5 volts.
Right. Just something we should probably mention. If somebody goes and plugs it into the wall socket to see the 60 hertz, they're going to fry it. So.
Yeah, nothing like a cooked Uno to brighten your
It wouldn't
day.
take very long either. Not with that.
No, yeah, it'd be pretty instantaneous. But yeah, you're right. But for what it's meant to do,
yeah, that's awesome.
Yeah, it's great. It's cheap, and there's nothing to it. So, so that was just too good to pass up. And then while we're talking about this one, I found this. This is a spectrum analyzer, and this is off of YouTube. And here's the code, or this is how the guy did it. I found this today and figured I'd have to.
Actually, that's something I'm kind of interested in, because one of my B project, I want to be able to record frequencies, so I'd be curious to see how he did it.
Right. So, but this is he's using the TVOut. And there's the display. I mean, it's working. So, of course, his circuit right here, I haven't read this enough to see, how he's actually doing it. I just thought this was cool, like the oscilloscope. And
yeah, we'll have to put that in the show notes, a link to it, so people can read it.
So, yeah. And then the last file that I've got, sorry, this is more of a, I started throwing every kind of text generation that I could on here. Same introduction as what I used before. And this is kind of similar to what this little effect right here is using the display as a block and creating a grid of text. And in this example, I'm just randomly choosing.
Gotcha.
Just randomly choosing characters, and then doing some basic, some basic things that you'd use on any display. Counting up and down. Now, one interesting thing that I found is that if you just use the print command, it scrolls up the screen very intuitively. So here you're seeing it scroll 25 lines, and it just drops off the top line to put the next line down at the bottom. So the library is very easy to work with.
Yeah, that's nice.
And then I've got some time functions, just to show formatting and things like that. So I can scroll through this as quickly or as slow as you like. But a lot of these were the kinds of questions that I was getting asked. How do you get time on the screen and have it formatted and placed properly? Well, the code we have gets that answered.
Right.
So I did make this random characters function. I did turn that into its own function, and I ran out of time. But essentially, I've created the movie Matrix. I've almost created the raining numbers
Yeah.
with this. So I just didn't. I kind of have it worked out in my head how to do the code, but I didn't have time to do it. So so here we can. Oops, sorry.
Got a fast mouse.
Yeah. Count from 0 to 200 and back to 0. Okay, well, there's how you do it. You want to scroll some lines through the screen. Well, here's how we do it. So very simple. Oh yeah, I don't need that line anymore. So want to scroll some more lines. Nothing like fixing your code live. But these print functions, there's a print and there's a println, which automatically puts in the carriage return. I didn't use it here because I wanted to display how the scrolling worked. But it scrolls very nicely. It's a good library. So here's some counting time. How do you format it right? That's what it's there for. Now, somebody, if they're watching this carefully, will see that I'm using the TV delay rather than the regular Arduino delay. The reason for that is this delay actually is aware of the delay that is encountered when the timer goes off. Because in using the timers, you're running code, the timer stops, it executes a little code that you say run every however often the timer occurs, and then you go back to your regular code. Well, that little extra will add up over time. So the TV delay right there will help compensate for that.
All right.
And then counting up. And these were the questions that I was getting asked: is how do you display this? So, I figure if somebody has watched some of our other our other demos, okay, well that you have a number, you divide it by 60, now you have minutes, and since that's an integer, you're throwing away the remainder. If you want the remainder, you use modulo and net. Okay, so that there's nothing terribly new right there. And then this random screen, this random screen. Essentially, what I'm doing is I calculate the number of characters that's in X. I calculate the number of characters in Y that I can get, which now I've got X, Y, and I've essentially got an address grid of characters, which in this case is, with the 6 by 8 font, it's 22 by 12. And I don't remember what the 4. We were displaying the 4 by 6 font earlier, and I don't remember how many I get. But to do the random, I just give me a random X, give me a random Y, and then all of the characters are in between ASCII codes 32 and 129. And I did add 120. What I call 129 in here is actually ASCII 219, because I actually came in here, and this is the font. This is the font file.
Okay.
Actually added. It went through by itself character 127, which is the delete key, which is essentially just put nothing on the screen. I added this next one to be the block that you can use, that you need if you want to do a matrix like raining number.
Right. Okay. So you added the font in.
I added the font on the 6x8 and the 4x6, which are two of the fonts that come standard with the library. It's also got an 8x8 pixel font as well. So this is the 4x6 font that's appearing, and I don't know how many I've got across here, 30 something. But it's just randomly placing them, and of course the inputs to this function are, choose your font size, how long do you delay between each update, and how many steps do you want. And I think I've got it set. I think the demo right now is running 50 milliseconds and 1,000 steps. So, but you could run that.
Yeah.
For a long time if you wanted to. And then of course I stick in something like that just for fun. So, that I guess this line of code gives you an idea of, warped sense of humor. So
yeah, but your comments are sensible.
Yeah.
That's you generally know. Of course, sense of humor is reading people's comments sometimes.
Yeah. And then, here's the Let's Make It demo, or intro, which is the same code as what's elsewhere. And this centered X and centered Y, if the author of this library is interested in me adding to it, I'll put these in the library itself for somebody else to use in the future. So, but surprisingly, it's a powerful library, and even though I griped and complained extensively about how long it took me to get this stupid thing to work, once I got the right resistors in place, it's a nice library, and it's easy to use, and it's if you can dream it up, you can get it on the screen. So I don't think last time you sent me the actual schematic, I was going to draw it up in Eagle and stick it out on the website. If you send it to me, I know it's super simple, but yeah, it is. The schematic, I literally am using this right here.
Okay, it's exactly that. Okay, maybe we'll just point into that then.
Exactly this, and the only difference is that I have a 100 ohm resistor in between this audio pin and my speaker.
Okay.
And it's a very basic, half watt, 8 ohm speaker.
Okay.
So, now, one thing while we're talking about the speaker is I could not get this to work on the television. I'm guessing there is just not enough signal coming out of the Arduino for this TV to pick it up. Because I did try, this audio cable is actually connected to the back of the TV still, and I could never get it to work.
Yeah, so it may require some kind of op amp or something to boost it up.
I would need some sort of amplifier on it to get the signal strength up a little bit, because the Arduino just isn't powerful enough.
Yeah, I guess the other hard thing is finding a TV that can still do composite.
Yeah,
they're harder and harder to find.
Yeah, I've been looking around for composite displays, and there aren't very many of them around.
No.
So I'm going to change this back to my comments, because this is I like this. And we'll upload it and save it. Yeah, I don't know if you caught it, that shift.
Yeah, I saw that. Are you sure it isn't your monitor doing the shifting, adjusting?
No, it's in the library.
Okay.
It's the way the thing is getting set up. But you can see how this, once I have this random display going, you can tell how easy it is to switch this to a matrix.
Yeah.
Random number display. So I'll probably do that just
for fun.
Yeah, just because I can. So, so there's the.
So Jim asked about what about brightness and contrast in TVOut.
This television has a little bit. I think if you were to put some sort of pot resistor on here, you could tweak it a little bit. But your resistors have got to be pretty close. But because this is coming off an Arduino, you're not getting color. Essentially, all you're getting is black and white.
Right.
I know this when I'm looking at the video, it looks blue to me, but in reality, it's pretty much a gray.
Okay.
In looking at it, it's pretty much a gray monitor.
Right, and you can't adjust the grayscale. Is that correct?
No.
Okay.
Not with an Arduino, no. And I haven't even. The library doesn't support that level of detail.
Right. Okay. Well, yeah, that's the question that was from Jim. That's why I was asking those. So.
Well, it's meant for an Uno. So.
Right.
It's powerful. It does really well for what it's meant to do. But we're not going to get color TV off this. So there is a limit to what we can do. So, but it's I've enjoyed playing with this. So while you've been doing Eagle, I've been playing with this. So
yeah, it's good.
It's been fun, and I can very easily see where I'll use something. The only one of the limitations that I guess somebody does need to be aware of is because it's using Arduino timers. You're limited to what you can connect to the Arduino elsewhere. Okay, because you've got to use the dedicated pins that the Arduino timers are connected to.
Right.
So like on this Mega, okay, well, if I wanted to use 29 for something else like the keypad, well, I couldn't do it because I'm stuck. Right,
because they're attached to the timer.
That's right. So now, and if I wanted pin 10 back, then I'd have to get rid of the audio.
Right.
So that's the limitation. But thankfully the Mega has got gobs of I/O pins, and working around one pin wasn't a problem. So, but it was this has been a nice demo to write up.
That's cool.
So, all right, let me. All right, so now you get to see the screen the way it's meant to. So. But yeah, it's been good, and it's a powerful it's a powerful library. So,
all right, well, that's great. That was a great. Even Chris in the chat room said it's a cool demo. So,
thank you.
All right, that took up the whole hour. That was awesome.
It's a. Well, you did 2 weeks with Eagle. I figure I had to come up with something good. So.
Yeah, that's okay. I mean, the Eagle stuff was fun. I mean, I'm getting to know Eagle pretty well now. I'm more liking it. So. I didn't know I guess it was the first week I did that, or I think first week I did that. They have a free version of Eagle now. It's kind of limited in what it can do, but it's a great way to learn.
Yeah. I think you're limited to what is it, like 2 by 3 inches, and
I think it's by centimeters, but yeah, something like that.
Yeah.
But you can still do the schematic side of it, and get to know the schematic side. You just can't do large board designs with it. But even the hobbyist version is like $69.
Yeah,
Which makes
that's true.
It's a bigger board. It's big enough for like doing a shield or something like that.
Right.
All right. Well, I think we will call it a night. Oh, so what are the round things behind you, Bob? They're CDs, aren't they?
Huh?
On the wall behind you? Somebody's asking what they are. In the frame?
Oh. Well, that's kind of that's a longer story. If somebody's watched this show for a while, they know I used to work for ST Microelectronics, and the fab that was in the Dallas suburb of Carrollton is the one I worked at. And when we were closing that site, ST decided they wanted to close this site and the one in Phoenix. And when we were closing it, we ended up printing. You can't really tell, but here, let me. Move this right here is actually a 6-inch wafer that you print computer chips on. I mean, that's what when you're building chips, you build them on silicon wafers. So that's the silicon wafer, and we came up with a commemorative, thank you for all the years kind of wafer, and it was printed with that mask. So there were, 2,500 of those wafers printed, and they all used that mask.
Oh, okay.
When I was doing that, I had to write some software and use some things that weren't available to me at ST. So I did a bunch of work at home to get that to work, and in the very fine print, everyone who worked at the Carrollton plant when the announcement was made, all 11 or 1,200 people, every one of them has their name printed on that wafer.
Oh, wow.
Now, the letters are only about, I think they're 100 microns tall.
Oh, so tiny.
Yeah, you need a microscope to see them. But everybody's name is on there.
That's cool.
And that was the mask that printed all of those. So, I guess in the show notes I could put in something about semiconductor manufacturing and masks, and
yeah,
that was my world for the decade plus that I was with ST, and several years that I was with TI before that is finishing out chip designs and turning it into something that manufacturing could use.
I think we could do a whole show on that. It'd be interesting. People would learn how they're made.
It is very interesting, and how it's made.
Uh-huh.
The Discovery Channel
show, I watch it all the time.
They actually did a segment on how computer chips are manufactured.
I don't know if I've seen that one.
So
how it's made and how they do it are the two things I watch them a lot.
Yeah, but that is so that was the deal. I used software in my own time, and my payment was I got the mask that actually did all the printing.
Wow. Did everybody else get a frame with that one in it?
No, that was a custom frame.
Oh, okay.
That was very expensive.
And
we won't tell ST that they paid for it, too.
Doesn't matter anymore, does it?
Doesn't matter anymore. Actually, I still do work for ST.
Oh, okay.
I do contract work for them. So, but no, that custom frame, and those masks are very expensive. When we bought that mask in 2009, that was $1,500 for a 7-inch piece of quartz.
Oh, wow.
So masks are very expensive. But yeah, we could I guess if we need a topic sometime, I could ramble on for a while about mask making and reticles and how computer chips are manufactured. So wouldn't be as good as how it's made, but it'd be fun.
All right. So anything else?
That's it. That's it for me tonight.
That's a lot.
I've gone on for a long time.
Yeah. All right. Well, I'd like to thank everybody for tuning in. Again, watch us on YouTube. Tell your friends about us. If you have a portable device, you can get us on any of the podcast locations, and we're also on Roku if you want to watch us on the big screen in your living room. So.
And send us questions, because most of this demo was based on questions people were asking.
Right, and I actually answered a couple questions today, and I think I created more questions. But so yeah, go ahead and ask. If I'm slow at responding or Bob's slow at responding, just give us some time. We get a little inundated sometimes with different stuff. So
we do have jobs, so
yeah,
they get in the way.
Yeah, the job.
Yeah.
All right, everybody. We'll see everybody next week.
Good night.
Night. For show notes for this show, contacts, and more, go to the TechZen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.